I am Radhakrishna, mathematics teacher. Today we are going to continue integration, second lecture. In our last class, we have discussed one method of integration, that is integration by decomposition, and today we are going to discuss another method, integration by substitution. Integration by substitution. Let us take integral f dash g of x into g dash x. Integral f dash g of x into g dash x dx. In this integrand, f dash is a function of g of x, then it can be integrated only when derivative of g of x, that is g dash x, is also present. Then what we do is, we substitute g of x is equal to t. Then differentiating on both sides, we get g dash x is equal to dt by dx. So g dash x dx is equal to dt. Then this becomes integral f dash t into remaining is dt. Integral f dash t dt is f of t plus c. Now we substitute t is equal to g of x. Okay, this is called integration by substitution. In every question, you need to identify the substitution, and when you are substituting something as t, make sure that its derivative is present in the same integrand, then only it will work. Let us see some examples. Integral sin x by cos cube x. In this question, sin x by cos x is tan x into what is the remaining 1 by cos square x, that is secant square x, into dx. Now you can see that derivative of tan x is secant square x, it is present there. So we put tan x is equal to t. Tan x is equal to t. Then differentiating on both sides, we get secant square x dx is equal to dt. Then it becomes integral t into secant square x dx is dt, t into dt. What is the integral of t with respect to t? It is t square by 2 plus c. Now we substitute t as tan x, it will be tan square x by 2 plus c. We can also write this as secant x into tan x. Then derivative of secant x is secant x tan x. So we can put secant x is equal to t. Then differentiating on both sides, we get secant x dx, secant x into tan x dx is equal to dt. Then it becomes integral t dt. What is the integral of t? T square by 2. So it will be t square by 2 plus c. Substituting t is equal to secant x, we get secant square x by 2 plus c. We are getting different kinds of answers, but both are correct. Does it mean that tan x is equal to secant x? No. That constant will be different. See, we can write tan square x as secant square x minus 1 by 2 plus c. Now, this is secant square x by 2 plus that c minus 1 by 2. Minus 1 by 2 is constant. C minus 1 by 2 can be taken as a new constant k. That is how these two are same. The constant can differ because there c is any arbitrary constant. Next example, integral e power x into 1 plus x upon sine square x e power x. Easily you can identify the substitution. This e power x into 1 plus x is the derivative of x e power x. Okay. So, put x e power x is equal to t. This is the given question. Since we have the derivative of x e power x there in the numerator, we put x e power x is equal to t. What is its derivative? Using product rule, 1 into e power x plus x into derivative of e power x is e power x into dx is equal to dt. Then this numerator becomes dt, e power x into 1 plus x dx is equal to dt. So, it becomes integral dt by sine square t. One by sine square t is cosecant square t. So, integral cosecant square t dt. What is the integral of cosecant square t? Minus cot t plus c, and t is equal to x e power x. So, final answer is minus cot x e power x plus c. Okay. Now, next question, next example. Integral tan power 4x dx. Here there is only one function, so nothing can be substituted directly. So, we need to modify. We can write 1 tan square x as secant square x minus 1. Tan square x into tan square x, tan power 4x is, and the second tan square x can be written as secant square x minus 1. Now, separate into two integrals. Integral tan square x into secant square x minus tan square x. Okay. In the first term, we can easily see the substitution. Derivative of tan x is secant square x, it is present. So, we can put tan x is equal to t. Okay. And in the second part, again we write this tan square x as secant square x minus 1. Then tan square x into secant square x minus, if you write say tan square x as secant square x minus 1, you will get minus secant square x plus 1. Okay. Now, Actually we have to substitute tan x is equal to t for first part, but without writing the substitution also we can solve this question. Here we can write secant square x into dx as d of tan x. D by dx of tan x is secant square x. Cross multiplying by dx, secant square x into dx can be written as d of tan x. So, I will write this as tan square x into d of tan x, this into this, minus integral secant square x dx plus integral 1 dx, right. Here we are integrating tan square x with respect to tan x. It is just like t square dt. Okay. Integral of x square with respect to x is x cube by 3. So, integral of tan square x with respect to tan x will be tan cube x by 3. Tan cube x by 3 minus integral of secant square x, tan x, integral of 1 x, then we can write a constant of integration plus c. No need to write separate constants for these three integrals. We can write only one constant at the end. Okay. This is the third question. Now, more examples. Integral secant x by secant x plus tan x whole power 4. Here, if you check the derivative of secant x plus tan x, d by dx of secant x plus tan x is equal to derivative of secant x is secant x tan x plus derivative of tan x is secant square x. Then taking secant x common, it becomes secant x into tan x plus secant x. Okay. Then if you see, look at the numerator, over here only secant x is there. If you have secant x plus tan x also, then we can put secant x plus tan x is equal to t and numerator becomes dt. So, how to get secant x plus tan x here? You need to multiply numerator and denominator by secant x plus tan x. So, this becomes secant x into secant x plus tan x upon secant x plus tan x whole power 5. Right, dx. Now, put secant x is equal to t, secant x plus tan x is equal to t. Put secant x plus tan x is equal to t. Then its derivative is secant x into secant x plus tan x into dx is equal to dt. Then this becomes integral dt upon t power 5. We have already discussed the formula for integral 1 by x power n in our previous class. Integral 1 by x power n is minus 1 by n minus 1 x power n minus 1. So, its integral is minus 1 by 4 t power 4 plus c, and substituting t, you will get the answer minus 1 upon 4 into secant x plus tan x raised to 4 plus c. Okay. So, some more examples. Integral secant x into ln secant x plus tan x. What will you substitute? If you remember, ln of secant x plus tan x is present in one of our formulae. What is that formula? It is the integral of secant x. Integral secant x is ln secant x plus tan x. So, derivative of ln secant x plus tan x will be secant x, is it not? So, we put this is the question. Integral of secant x is ln secant x plus tan x. So, derivative of ln secant x plus tan x is secant x. So, we will put ln secant x plus tan x is equal to t. Then directly you can write its derivative is secant x into dx is equal to dt. Okay. Then it becomes integral, this is t, remaining is dt. So, t dt. What is the integral of t? T square by 2 plus c. Substituting the value of t as ln secant x plus tan x, we can write ln square of secant x plus tan x by 2 plus c. Okay. Moving to next question. It is a previous JEE question. Integral x power 3m plus x power 2m plus x power m into mth root of 2x power 2m plus 3x power m plus 6 into dx. Integral x power 3m plus x power 2m plus x power m into mth root of 2x power 2m plus 3x power m plus 6 into dx. This is the question. So, directly looking at this and this, if you try to put sum of one of them as t, the other should be the derivative of the substitution. Usually, because it is under mth root, we try to substitute this as t. But what is its derivative? Derivative of the term under the mth root is 4m x power 2m minus 1 plus 3m x power m minus 1 plus 0. But nothing is there. its derivative is not there. So, it is of no use substituting this as t, and substituting this as t you will not get that. So, we need to rearrange the terms so that we can identify the substitution. See the rearrangement in this question. Let us send one x from here inside the mth root. Take x common from these three, take that x into mth root. Then what happens? This becomes x power 3m minus 1 plus x power 2m minus 1 plus x power m minus 1. I am sending that x into mth root, into mth root of, if x goes inside the mth root, it becomes x power m. So, we have to multiply this by x power m. This into x power m will be 2 into x power 3m plus 3 into x power 2m plus 6 into x power m dx. Now, look at this. What is its derivative? 6m x power 3m minus 1 plus 6m x power 2m minus 1 plus 6m into x power m minus 1. If you take 6m common, the remaining will be this only. So, by rearranging the terms slightly, we can identify the substitution like this. So, what to substitute now? Put 2x power 3m plus 3x power 2m plus 6x power m is equal to t. Differentiating it, you will get 6m x power 3m minus 1, here 6m x power 2m minus 1 plus 6m x power m minus 1. I will directly take 6m common. 6m into, what is the remaining here? X power 3m minus 1 plus here x power 2m minus 1 plus x power m minus 1 into dx is equal to dt. 6m is a constant, we can take it to right side. So, x power 3m minus 1 plus x power 2m minus 1 plus x power m minus 1 into dx is equal to dt by 6m. Now, over here this into dx becomes dt by 6m, and this is mth root of t. Mth root of t can be written as t power 1 by m and remaining is dt by 6m. Okay. Now, integrate it normally, it is 1 by 6m into, what is the integral of t power 1 by m? T power 1 by m plus 1 by 1 by m plus 1 plus c. Then simplify and also substitute t. T is 2x power 3m plus 3x power 2m plus 6x power m whole power 1 by m plus 1 will be m plus 1 by m divided by 6 into m plus 1. Okay. So, this kind of rearrangement is one technique in the substitution method, and we can also see more ideas while identifying the substitution in the further problems. Next question, integral x square plus 1 by x power 4 plus 1, and this is a standard model. In this question, in order to identify the substitution, we divide numerator and denominator by x square. This is a very good technique in many questions similar to this. Dividing numerator and denominator by x square, let us see what happens. Numerator becomes 1 plus 1 by x square by x square plus 1 by x square. Now, look at the numerator. 1 plus 1 by x square is there. It is the derivative of what? 1 plus 1 by x square is the derivative of x minus 1 by x. 1 is the derivative of x. 1 by x square is the derivative of minus 1 by x. Since this is the derivative of x minus 1 by x, we try to write the denominator in terms of x minus 1 by x. It is 1 plus 1 by x square by, how to write x square plus 1 by x square in terms of x minus 1 by x. A square plus b square can be written as a minus b whole square plus 2ab. So, I will write it as x minus 1 by x whole square plus 2ab. 2ab means 2 into x into 1 by x, that is 2. Okay. Dx. Now, we substitute 1 plus x minus 1 by x is equal to t. Its derivative is 1 plus 1 by x square dx is equal to dt. Then it becomes integral dt upon t square plus 2. Okay. Now, we have a formula, integral 1 by 1 plus x square dx is equal to tan inverse x plus c. Okay, or minus cot inverse x. From this, we can derive a formula for integral 1 by x square a square plus x square or x square plus a square. How to get? Taking a square common from the denominator, 1 by a square into, it becomes 1 by 1 plus x square by a square is x by a whole square dx. Okay. Now, assuming that x by a is some x or t, what is the integral using this formula? 1 by a square into tan inverse x by a, but we have assumed x by a as x. So, what to do? We have to divide by the inner derivative of x by a. What is the derivative of x by a? 1 by a. We have to divide by 1 by a plus c. Then you will get 1 by a tan inverse x by a plus c. So, all of you take this as a formula. Integral 1 by a square plus x square is 1 by a tan inverse x by a. Okay. And later in this class we are going to derive this kind of results separately by using trigonometric substitution. Okay. After completing few more examples, we are going to discuss trigonometric substitution. Okay. So now I am going to use that formula here. I will write this as t square plus, you can write 2 as root 2 whole square. It is exactly in that form. So what is the answer? 1 by a means 1 by root 2 tan inverse t by tan inverse t by root 2 plus c. Now substituting t, you will get the final answer 1 by root 2 tan inverse x minus 1 by x by root 2, we can write as x square minus 1 by x root 2 plus c. Okay. All of you should remember this technique, dividing numerator and denominator by x square. Usually when numerator and denominator are polynomials of even degree having only x square, x power 4, x power 6 kind of terms, we try this method. Now proceeding to next question. Integral 7x power 8 plus 8x power 7 upon 1 plus x power 8 whole square dx. This is the question. Here also you will not be able to identify the substitution directly. Usually we try to substitute this as t, but its derivative is 1 plus 8x power 7, but 1 plus 8x power 7 is not there. So we need to modify slightly, just like previous two questions, just rearrangement. Let us take x power 8 common from the bracket. But how to get the idea? How do you know that x power 8 should be taken common? You will be getting this kind of ideas by practice. Okay. Taking x power 8 common, x power 8 when comes outside it becomes x power 8 whole square, x power 16. So numerator should be divided by x power 16. I will first write 7x power 8 plus 8x power 7 by, after taking x power 8 common, you will get x power 16 into, this becomes 1 by x power 8 plus 1 by x power 7 plus 1 whole square into dx. Now if you divide numerator by x power 16, you will get 7 by x power 8 plus 8 by what, x power 9 by this 1 by x power 8 plus 1 by x power 7 plus 1 whole square dx. Now you observe it, derivative of the term present in this bracket is, derivative of 1 by x power 8 is minus 8 by x power 9 with minus sign. Derivative of 1 by x power 7 will be minus 7 by x power 8. So if you have minus sign here and here, it becomes the derivative of denominator. Okay. So, put 1 by x power 8 plus 1 by x power 7 plus 1 is equal to t. What is its derivative? Minus 8 by x power 9 minus 7 by x power 8 dx is equal to dt. Now, taking minus sign common, you can multiply both sides by minus sign, then you will get 8 by x power 9 plus 7 by x power 8 into dx is equal to minus dt. Now, this becomes, numerator is minus dt, denominator is t square. What is the integral of minus 1 by t square? 1 by t. 1 by t plus c, and substitute t. 1 by x power 8 plus 1 by x power 7 plus 1 plus c, and now you can simplify, take LCM and simplify. Okay. So, you please observe the techniques used in 6th question, 7th question and 8th question, and improve your ideas. Next question. Integral 1 upon secant x plus cosecant x plus tan x plus cot x whole square. Dx. Let us simplify, because if you try to substitute the entire term as t, we do not have its derivative. So, we need to simplify. Write every term in sin and cos. 1 upon 1 by cos x, secant x is 1 by cos x, plus cosecant x is 1 by sin x, plus tan x plus cot x. Tan x is sin x by cos x, and cot x is cos x by sin x. Whole square dx. Now, combine these two and these two separately. 1 upon, if you take LCM, LCM of these two is cos x into sin x, numerator becomes sin x plus cos x by cos x sin x. Plus, if you take LCM, cos x sin x is LCM, numerator becomes sin square x plus cos square x, which is 1. So, it is 1 upon cos x into sin x whole square. Now, they have common LCM, same LCM. So, we can write cos x sin x as common denominator, then it becomes cos square x sin square x, and it will go to numerator. What will you get? Cos square x into sin square x by sin x plus cos x plus 1 whole square. Okay, we cannot simplify further. Now, what to do? if you multiply and divide by 2 square, this becomes 2 sin x cos x whole square, which is sin square 2x. Okay. One by 4 into integral sin square 2x by sin x plus cos x plus 1 whole square, okay, dx. Now, in many questions in trigonometry and integration, we use one important result, 1 plus sin 2x is equal to sin x plus cos x whole square. Very simple to understand. If you expand sin square x plus cos square x 1 plus 2 sin x cos x, that is sin 2x. So, I will write sin 2x as sin x plus cos x whole square minus 1. Sin x plus cos x whole square minus 1. What is this? Sin 2x, but again square is there, by sin x plus cos x plus 1 whole square. Dx. Now, it is almost finished. This can be written as a square minus b square is a plus b into a minus b, no? So, if you write 1 as 1 square, a square minus b square is a plus b into a minus b. So, 1 by 4 into integral a plus b means sin x plus cos x plus 1 into a minus b means sin x plus cos x minus 1, but again whole square is there. So, you will get square for both the brackets, and denominator is sin x plus cos x plus 1 whole square into dx. Now, you see this is cancelled and remaining is sin x plus cos x minus 1 whole square. How to integrate? Expand the square. If you expand the square, you will get 1 by 4 into integral a plus b plus c whole square sin square x plus cos square x, that is 1, again 1 square is 1, so total 2, okay, plus 2 sin x cos x plus 2 sin x cos x, I will write it as sin 2x. Then you will get minus 2 sin x minus 2 cos x. Dx. Now, what is the integral? 2x, 1 by 4 into 2x, integral of cos sin 2x is minus cos 2x by 2, next integral of sin x is minus cos x, integral of cos x is sin x, substitute. Okay. I am going to proceed to next question. Integral 1 by e power x plus 1. I will explain 2 or 3 methods for this question. In one method, method 1, since the derivative of e power x is e power x, we will multiply and divide by e power x. It becomes e power x by e power x into e power x plus 1 dx. Now, since e power x is the derivative of e power x, we put e power x is equal to t. Differentiating, derivative of e power x is e power x into dx is equal to dt. Then this becomes integral dt by t into t plus 1. Now, we have to follow decomposition method. How to decompose this into a sum or difference? Numerator is 1. We can write 1 as t plus 1 minus t by t into t plus 1. Now, separating the denominator, you will get 1 by t minus 1 by t plus 1. Okay. Now, both are known integrals. Integral of 1 by t is ln mod t minus integral 1 by t plus 1 is ln mod t plus 1. Plus c. Okay. Now, ln a minus ln b is ln a by b. So, it will be ln mod t by t plus 1 plus c. Substitute t as e power x. Final answer is ln mod e power x by e power x plus 1. This is method 1. Now, method 2. Here we have multiplied and divided by e power x. In method 2, we will write numerator as e power x plus 1 minus e power x. So, we have added e power x and subtracted e power x by e power x plus 1 dx. Now, separating the denominator, e power x by e power x plus 1 by e power x plus 1 is 1 minus e power x by e power x plus 1. Right. Integral of 1 is x minus, over here observe that derivative of denominator is numerator. Derivative of e power x plus 1 is e power x. So, it can be treated as f dash x by fx. What is the integral of f dash x by fx? We discussed in the last class. Integral f dash x by fx is ln mod fx. So, it is ln mod e power x plus 1 plus c. That second method is shorter than this method, but both answers are same. Okay. Now, one more method, method 3. In this method, it will be too short. I will take e power x common from the denominator. Then I will get e power minus x by 1 plus e power minus x. Is it not? I can write this like this. Now, what is the derivative of denominator? Derivative of 1 plus e power minus x is minus e power minus x. So, if you can put minus sign here, it becomes the derivative of denominator. So, I will put minus sign here and outside. Now, it is f dash x by fx. So, integral is minus of ln mod 1 plus c power minus x plus c. This is the answer. Okay. Next question. Integral 1 by x into x power n plus 1. The technique is same as 1 by e power x plus 1. In method 1, we multiply and divide by x power n minus 1, it becomes x power n minus 1 by x power n into x power n plus 1. Now, if you put x power n is equal to t, derivative of x power n is n x power n minus 1. So, multiply by n here, divide by n. Then, if you put x power n is equal to t, it becomes 1 by n integral dt by t into t plus 1. You know how to solve it, I have explained in the previous question. This is method 1. Method 2, in method 2, we write numerator as x power n plus 1 minus x power n, just like the second method of the previous question, by x into x power n plus 1. If you separate the denominator, it becomes 1 by x, this by this 1 by x, minus x power n by x into x power n plus 1 will be x power n minus 1 by x power n plus 1 dx. Derivative of 1 by x is, integral of 1 by x is ln mod x. What will you do here? If you multiply and divide by n, it becomes f dash x by fx. Finished. Okay. In method 3, we will take x power n common from the denominator, then we will get 1 by x power n plus 1 into 1 plus 1 by x power n. What is the derivative of 1 plus 1 by x power n? Derivative of 1 plus 1 by x power n will be minus n by x power n plus 1. 1 by x power n plus 1 is there. What else you need? Minus n. So, if you multiply and divide by minus n, it becomes f dash x by fx. Is it not? So, integral is log mod of x. You finish it later. We will proceed to next question. It is a nice question. Integral cos 7x minus cos 8x upon 1 plus 2 cos 5x. Actually, it is a question from decomposition. No need of substituting anything. We have to manipulate and decompose it so that each term is integrable. Now, multiply and divide by sin 5x, so that this 2 cos 5x sin 5x becomes sin 10x. I will multiply and divide by sin 5x. Sin 5x into cos 7x minus cos 8x by, we will get sin 5x plus 2 cos 5x into sin 5x is sin 10x. Okay. Now use transformations. We can write the denominator as sin c plus sin d, 2 sin c plus d by 2 cos c minus d by 2. Take larger angle as c. 2 sin c plus d by 2 is 10x plus 5x, 15x by 2 into cos c minus d by 2 is 10x minus 5x by 2, that is 5x by 2. Okay. Now numerator, we can write sin 5x as 2 sin 5x by 2 cos 5x by 2. After getting this term, we get that idea. 2 sin 5x by 2 cos 5x by 2. Okay. Here cos c minus cos d. Cos c minus cos d is sin 2 sin c plus d by 2 sin d minus c by 2. So it is 2 sin c plus d by 2 is 15x by 2 into sin d minus c by 2, 8x minus 7x by 2 is x by 2. Now it is almost over. 2 cancels, cos 5x by 2 cancels, sin 15x by 2 cancels. Okay, into dx. What is remaining? 2 sin 5x by 2 sin x by 2. Now 2 sin A sin B formula. 2 sin A sin B is cos A minus B minus cos A plus B. So it is cos A minus B is 5x by 2 minus x by 2 is 4x by 2 or 2x minus cos A plus B, 5x by 2 plus x by 2 is 6x by 2, that is 3x. Now it is finished. What is the integral of cos 2x sin 2x by 2 minus integral of cos 3x sin 3x by 3. Plus c. So that is the final answer. Next question. Integral secant power 4 by 9x cosecant power 14 by 9x dx. In this question, first you write it as 1 by cos and 1 by sin. We get 1 by cos power 4 by 9x sin power 14 by 9. You observe the numbers. Is there any relation between 4 by 9 and 14 by 9? If you add them, you are getting 2. The sum is 2. So, if you divide by cos power 14 by 9 and multiply by cos power 14 by 9, this becomes cos square x. This becomes cos square x, dividing and multiplying by cos power 14 by 9. Okay. Now, this is tan power 14 by 9, 1 by cos square is secant square. So, it is integral secant square x by tan power 14 by 9 x dx. Now, secant square x is the derivative of tan x, so put tan x is equal to t. Okay. Then secant square x dx is dt. Then it becomes dt by t power 14 by 9. You can integrate. I have given the formula for integral of 1 by x power n. What is it? Minus 1 by n minus 1 x power n minus 1. So, minus 1 by n minus 1 means 14 by 9 minus 1, 5 by 9 t power 5 by 9 plus c, substitute t. Okay. Now, another question. This question is also based on decomposition. By manipulating the terms, we have to get it simplified. Let us write numerator as cos 5x plus cos 3x Now, let us keep the numerator as it is because it is smaller than denominator. I will try to simplify denominator. 5 cos 3x plus 10 cos x. In the denominator, let us write the first two terms as cos 6x plus cos 4x. So, I have separated cos 4x plus what is the remaining 5 cos 4x now. I will write 5 into cos 4x plus separate 5 cos 2x plus cos 2x. So, 5 cos 2x is separated, another 10 cos 2x is there. So, 10 cos 2x plus 10 can be written as 10 into cos 2x plus 1, right. Now, apply transformations to each bracket. Cos 5x plus 5 cos 3x plus 10 cos x by cos c plus cos d, 2 cos c plus d by 2 cos c minus d by 2. 2 cos c plus d by 2 is 5x, cos c minus d by 2 is x plus 5 into again cos c plus cos d formula, 2 cos c plus d by 2, c plus d by 2 is 3x and c minus d by 2 is x plus, all of you know this formula, cos 2x plus 1 is 2 cos square x. So 10 into 2 cos square x. Now you can take 2 cos x common from the denominator. Numerator as it is. From the denominator, if you take 2 cos x common, 2 cos x into, you will get cos 5x remaining here plus 5 cos 3x from here plus 10 cos x. What happens? These two will cancel. Now it is 1 by 2 cos x dx, that is half integral secant x dx. It is a direct formula. Okay. So with this we have almost discussed the ideas behind the substitutions, how to get the required substitution and how to identify the substitution, manipulation techniques and rearrangement techniques, etc. Now I am going to explain about a particular substitution called trigonometric substitution. What is trigonometric substitution? If you observe the terms a square minus x square, usually with square root, or a square plus x square, or root over x square minus a square. If you see this kind of terms in the integrands, a standard trigonometric substitution will work. For this kind of terms, we substitute x is equal to a sin theta. You remember the substitutions, please copy. For root over a square plus x square, we put x is equal to a tan theta, or x is equal to a sin h theta, hyperbolic substitution. For root over x square minus a square, put x is equal to a secant theta, or a cos h theta. All of you remember these substitutions, then we can derive some formulae. Okay. Integral 1 by root over a square minus x square dx is sin inverse x by a. We can prove it by trigonometric substitution. How? Put x is equal to a sin theta, as we discussed in the previous slide. Put x is equal to a sin theta. Then dx is equal to, derivative of x is 1, 1 into dx is equal to, derivative of a sin theta is a cos theta into d theta. Now this becomes integral 1 by root over a square minus a square sin square theta. It will be root over a square cos square theta into dx is a cos theta d theta. Now this is a cos theta, a cos theta cancels. What will you get? Integral 1 d theta. what is the integral of 1? It is theta plus c. Then substitute theta, x by a is sin theta, then theta is sin inverse x by a plus c. So, this is the proof of this formula. Next formula, 1 by integral 1 by root over a square plus x square dx is sin h inverse x by a plus c or ln of x plus root over x square plus a square. Here I gave two substitutions. You can put x is equal to a tan theta or a sin h theta. Okay. I will explain both. First, putting x is equal to a tan theta, then dx is equal to a secant square theta d theta, then this will be 1 by root over a square plus a square tan square theta is root over a square secant square theta, 1 plus tan square theta is secant square theta. So, this becomes a secant theta into dx is a secant square theta d theta. A secant theta cancels, it is secant theta. Now, what is the integral of secant theta? Ln mod secant theta plus tan theta. Okay. Now, substitute tan theta as x by a, and what is secant theta? Root over 1 plus tan square theta, that is root over 1 plus tan square theta means x square by a square plus x by a plus c. Now, taking a LCM, it becomes ln of root over a square plus x square plus x by a plus c. Ln a by b is ln a minus ln b, no? So, you can write this as ln of numerator minus ln of denominator. Ln of denominator is a constant, ln a is constant, that can be included in c. So, when you are writing c, no need to write this a. So, this is proved. Okay. Now, in the other method, one by root over a square plus x square, put x is equal to a sin h theta, and for proving this you need to have some knowledge in the formulae of hyperbolic functions. Dx is equal to derivative of sin h theta is cos h theta. So, a cos h theta d theta, then 1 by root over a square plus a square sin h square theta into a cos h theta. In hyperbolic functions, 1 plus sin h square theta is cos h square theta. Okay. Then this becomes a cos h theta. 1 by a cos h theta into a cos h theta d theta. These two will cancel. What is the remaining 1? Integral 1 is theta plus c. What is theta? X by a is sin h theta. Theta is sin h inverse x by a. Okay, and all of you remember that sin h inverse x by a is equal to a logarithmic function. Next formula, 1 by root over x square minus a square. Its integral is cos h inverse x by a, or ln of x plus root over, it is x square minus a square. Okay. It can be proved in the same way as the second result in both the substitutions, either putting x is equal to a secant theta or x is equal to a cos h theta. Okay. Now, I have already explained this. Integral of 1 by x square plus a square dx is equal to 1 by a tan inverse x by a, and I have already proved by taking a square common, we have proved this result. It can also be proved by trigonometric substitution, putting x is equal to a tan theta. Okay. Now, in the same way, we can prove that integral root over a square plus x square dx is equal to this integral root over, this is a square minus x square, this is a square plus x square, next is root over, this is x square minus a square. Okay. I will prove one of them. I will prove the last one. In the same method we can prove remaining. Okay. Integral root over x square minus a square dx. What is the substitution? Put x is equal to a cos h theta. Then dx is equal to a sin h theta d theta. Then this becomes root over a square cos h square theta minus a square. Into dx is a sin h theta. Taking a square common, cos h square theta minus 1 is sin h square theta. So, it becomes root over a square sin h square theta, which is same as this. So, finally, this into this becomes a square sin h square theta. Now, multiplying and dividing by 2, a square by 2 into 2 sin h square theta can be expressed as cos h2 theta minus 1. It is a formula in hyperbolic functions. Okay. Now, what is the integral of cos h2 theta? It is sin h2 theta by 2 minus theta. Now, sin h2 theta can be written as 2 sin h theta cos h theta. So, 2 cancels, a square by 2 into sin h theta cos h theta minus theta. Now, cos h theta is x by a, sin h theta will be the relation is sin h square theta is equal to cos h square theta minus 1. So, it is a square by 2 into, this is x by a, cos h theta is x by a, sin h theta is root over x by a whole square minus 1. Minus theta, x by a is cos h theta, so theta is cos h inverse x by a plus c. If you take it inside, if you take a square inside, then you are going to get this result. Okay. In the same way you can try this, but actually there is one more method which comes later, that is integration by parts. Using that method the proof will be very easy. Okay. So, for the time being, if you are not familiar with hyperbolic functions, leave it, do not worry. Okay. So, with this we are going to close the session for today, and we are going to solve questions on this trigonometric substitution and these results in the next class. Okay. So, thanks for watching, have a good day.